just thought I'd have a quick look and see how this dome failed. So it does seem to be related to tension forced on the acrylic by the collapsing housing. So obviously, shaped like that normally collapses as it goes in the way and tries to bend the acrylic, and acrylic not particularly good in tension. Obviously, dome's very strong in compression, and it's gone along here, along this side where it's been bent in. There does seem to be either stopping or starting at the screw holes, which is interesting. But yeah, I'll cut it open and have a look at the see what kind of cross section there is of plastic. Because it looks like it's very thin at the top. It'll be interesting to see how thick it actually is, and it's interesting to note that the cracks are actually on the thickest part of the acrylic after it just turns the corner and not right in the face. It's possibly less flexible right here when it's thickest. Yeah, I'll go down here and have a look. Very thin at the top. It's like maybe only 2 millimeters at the top, and a lot thicker at the bottom. It's interesting. Seems to have cracked along the. Might just be coincidence, but it's quite a lot misshapen and pointing that way. Possibly because the acrylic was too hot, or maybe no. There's lots of factors that could have caused that. Well, that's interesting. Give that a wee measure, see what it is. It's obviously 8mm acrylic here, or when it started anyway. Maybe a bit thinner now. Yeah, around about 8. Tapering down to the middle, which is, yeah, well, 1.5mm or something. Wow. Testament to the power of the dome. So this dome structure was able to survive pressure at up to 20 bar, 200 meters equivalent depth. So that's really quite impressive. Don't know if it needs this reinforcing on the side. That's just kind of the way the acrylic blows. Wow. Yeah, it's too thin. 1.5mm. We'll go to 200 meters. It's the right shape. Wow. Pretty surprising. So I might cut open the housing as well. Might give me some clues about the positioning of the screws. This is the main one I want to find out. To see if you can see if we can make a jig that would aim the pilot holes that you drill to take these fixing screws down through the outside of the case, so it doesn't puncture the case by going in the way. It doesn't come out and weaken the holding effect of the screw. But yeah, it's surprising and interesting to see. even on the this is the thinnest part, and this is the part between the these kind of ribs. I guess must reinforce it a bit. The thinnest part, it's 8.5 mil, 8 point, yeah, 8.5, 8 mil. That seems to be quite a uniform thickness all the way along. And the front, obviously, I've modified it. Sanded it down quite a lot at the front here to get a nice flat face to mount it on. So I imagine that thickness came all the way around, maybe it was even a bit thicker on the base before I sanded it flat. Some very little stress marks. There's one there from the screw. And I was just eyeballing this, you know, to try and get the screws to come straight down the edge. It probably doesn't matter too much if they kind of go out with, because you don't need much force to hold it down, especially if it's just taking a external pressure rather than gas compensating. Interesting, quite a solid thing. Obviously it's got these nice buttress threads on here pointing one way. I can take the force from internal pressure. It's designed, but it's obviously got the O-ring, big fat O-ring. Look at it. You can see here how it works. Big fat O-ring sits in there, so there's no, and it compresses it, squashes it down when you screw the end on, and obviously it's captured O-ring as well, so it can't. It's right in the corner, so it can't go out and it can't come in once you've screwed it down inside the end cap. Yep, doesn't like being chopped in half or squashed at 20 bar. But that's kind of the idea. I'm just thinking about some kind of jig that we could. So we know the thickness now, 8 mil or thereby. Of the surface, so we know if we set up a jig on the outside with some kind of ruler system, we know that if our center our holes 4 mil in or even angled slightly out, we should be able to drill a pilot hole which will guide the screw away and stop it puncturing the inside housing here. Or maybe we can use less or even connect internally through here. Lots of options. Nice. More results from the test. To get a few more of these housings and test the idea of having a dome. I was kind of thinking it was going to be more difficult, make it a more difficult build with a dome in the front. You know, with the complication of heating up the acrylic and blowing it and whatnot. Versus the idea of having a cylinder on the front, like open ROV type design with acrylic tube with end caps, O-ring sealed. But yeah, the capped acrylic tube idea is kind of becoming more complicated, because you obviously need to be able to. You have it on front, you need to connect it into the body of the ROV and to the electronics, obviously the wires that will come through for the cameras and whatnot. So yeah, I'm kind of struggling at the moment with so just laced up on my very basic lathe here, just on the drill with the threaded bar through it, through a piece of wood. Very basic. The end caps seem to be fairly doable. Just carefully measuring the groove and careful not to put too much depth on the O-ring groove, which will make it not compress enough. It's fine. What I'm struggling with is taking the the wires out. So what I was trying in the last ones is tapping out this thread, but this is a 1/8 BSP parallel thread onto a hose barb, and I've tried. This is my test patch here. You know, I tried 30 odd goes to try and get this to work, and I thought I had it just with I had 2 taps in the pack, and one of them was working, one of them wasn't. I think just based on the angle of the lead-in on the end of the tap. But then I tried it in this one, stripped the threads, and also on the low density polyethylene, stripped the threads on that. I haven't tried the high density polyethylene yet. This is medium density polyethylene, at least I think it is. It's water pipe. It was a bit more rubbery than normal blue plastic pipe, and it smelled a bit funny when I was heating it. Kind of like there's other impurities, almost like creosote or oil or something. Same problem. It didn't quite take the thread right. That's kind of the idea. So now I'm thinking about drilling out a nice neat hole and then having something like this, maybe a double-ended hose barb, and doing an O-ring groove in that, putting it in, and then somehow having the washer on here hold down the hose barb, stop it popping out when you're pressure testing. And obviously when you've got external pressure, I'll try and push it in. Anyway, but yeah, plastic, the medium density polyethylene seems to flow very slowly, but it does definitely flow. This I had in the oven overnight, like 5 hours, 8 hours or something, at 200 degrees. And this is the same blue one that was in the first turning end cap video. Yeah, just heated it up and left it overnight, again in the oven at 200 degrees. And it's flowed pretty nicely. There's obviously a bubble there and it's a bit squinty and whatnot. But moulding it in a bean tin seems to work pretty effectively. Wind up with a nice circle shape. So that's an option. I did go out and buy a big chunk of high density polyethylene on eBay. Yeah, I've just been so it's a 70mm by 500 chunk for 20 GB pounds. It's quite reasonable. You know, you get 20 end caps out of this quite easily for 20 quid. It's nice the idea you can just melt down a piece of pipe in a bean tin, you get your end caps, and spin it on a drill, keep it low tech. Quite like the idea of trying to maintain the makeability of it, keep it as low tech or makeable as possible, just with DIY type technology. Obviously, as much as possible open source hardware, you can look into that. So that's where I'm up to. So I might, I haven't got the hose barbs yet, so I might do a pressure test just with the without any through end cap connections, and just see what the end caps can take and the acrylic, because I'm expecting now that maybe the acrylic will go before the end caps. But we'll see if the test chamber can take it up that high. I'm fairly confident it'll. These end caps are good. And obviously a very simple sealing here as well, around the threaded bar, which will be used for mounting the tube. It also seals just with PTFE. So what I have been doing is putting like 20 odd turns around the back of the washer, and then 20 odd turns around the front, putting it in, That seems to seal okay, but on some of them I was even doing the same thing, doing more turns here of PTFE, a washer, more PTFE, and then another bolt. It seems to seal pretty well. Obviously I can't test them without some way of putting air in it. And they'll need to think of some way of dismantling it, because obviously the original idea was to have it gas compensated and have this pressurized before it went in the water, and I still like that ability, so that we can test for leaks before we put it in the water. And then the only problem come up so far is the friction generated on these O-ring seals is greater than the friction generated on the bolts that go through. So what happens if you put a spanner on the threaded bar, trying to unscrew the end cap, what you do is unscrew the fitting, which is obviously compromising that watertight seal. Being just a tape seal, it's going to quickly become damaged and not usable if I keep doing that. So some way of locking the bar to the end cap might be good. Some kind of, or maybe even just a couple of holes there and some tool, like a grinder tool, you know, with two prongs that stick in. So you're turning the end cap and not the threaded bar. That's where I'm at with this. I'd quite like to do another pressure test and see how the plastics compare. Low density, very doable. You know, even plastic bags, if you can't get a bit of chopping board, and it flows dead easy. Even easier to machine than medium density polyethylene or the high density polyethylene. So that definitely a solution. Low density. Medium might be stronger, certainly kind of rubber, more rubbery. So it might allow more flex before it breaks. On the high density polyethylene, it's pretty inexpensive. Get a huge block of it for 20 quid. Yeah. Lots to test out. And quite a few results from this one, so it's awesome. Do some more testing. One day I'll get something in the water.